Hi there and welcome to tutorial 19 on linear transforms of discrete random variables. This is for the Edexcel S1 A-level module and is applicable to most other exam boards. As always, if you're looking for further help with your studies, do check out youtube.com/Mr. Arnold's Maths. Okay, so let's take a look at a couple of probability distributions, and we're going to discuss here transforming the expected value of x to the expected value of ax. So what happens? So if I have a six-sided die with 0, 0, 1, 2, 2, and 2 all on the faces, this has a probability distribution given below. Suppose I was to work out the expected value of x, it would be 0 times 1/3, 0 times 1/3, plus 1 times 1/6, plus 2 times 1/2. And when we work that out, that's 1/6 plus 1, so 1 and 1/6, 1 and 1/6. Let's have a look at another six-sided die which has 0, 0, 3, 6, 6 and 6, and this has a similar probability distribution to the one we just did a second ago. So suppose I was working out the expected value of y, it would be 0 times 1/3 plus 3 times 1/6 plus 6 times 1/2, and that leaves us with, well, that's a half, so it's going to be 3 and 1/2, 3 and 1/2 altogether. Now you may have noticed something, and that's the fact that y is the same as 3 times x. So if you notice, if I times everything in x by 3, I end up with y. So if I times 0 by 3, I get 0. If I times 1 by 3, I get 3. If I times 2 by 3, I get 6, etc. So we got y is equal to 3x. Now, if we look at the expected values for both, we might notice something as well. What happens if I times this by 3? If I times that by 3, well, 3 times 1 and 1/6 gives me 3 and 1/2. So that leaves us to our first transform. The expected value of y is equal to 3 times the expected value of x. So in general, if I want to transform a variable x to ax, all I do is work out the expected value of x and then times it by a. So that's our first transform there. Okay, what about an example? So suppose I have a discrete random variable with a mean of 1.3 and I'm asked to find the expected value of 4x. Well, we know from the question that the expected value of x equals 1.3. That means the expected value of 4x equals 4 times the expected value of x. Which is going to be 4 times 1.3, and 4 times 4, 8, 12, so that's going to be 5.2. So very straightforward there. Work out the expected value of x and then just multiply it by 4. Okay, what about a different type of transformation? So if I have the expected value of x and I want to transform it to the expected value of x plus b, where b is some number. So again, we've got our six-sided die with 0, 0, 1, 2, 2, and 2. And then we have another six-sided die with 2, 2, 3, 4, 4, and 4. Just like before, the expected value of x here is going to be 1 and 1/6. And let's work out the expected value of y. So it's going to be 2 times 1/3 plus 3 times 1/6 plus 4 times 1/2. Let me see, that's going to give me 2/3 plus 1/2 plus 2. Let's just use the calculator for this to save a wee bit of time. So 2 over 3, and let's get it in the right mode. Let's put it in regular mode. So we got 2 over 3 plus a half plus 2. And that gives us 19 over 6, which is 3 and 1/6. 3 and 1/6. So that's 3 and 1/6. Now, let's just take a look at our random variables again. Notice that y is the same as x plus 2. So y is the same as x plus 2. And look at our expected values at the end here. If I take my expected value x and I add 2 to it, so if I add 2 to this, I actually get this. That will give me 3 and 1/6. So the expected value of y is equal to the expected value of x plus 2. So in general, if we transform a variable, the expected value of x plus b is simply the expected value of x plus b at the end. So let's take a look at a quick example. So I got my discrete random variable with a mean of 1.3. So I want to find the expected value of x plus 3. Well, the expected value of x equals 1.3. That means the expected value of x plus 3 will equal the expected value of x plus 3, and the expected value of x is 1.3, which gives me 4.3. So that's how we transform a discrete random variable. Now, let's just kind of put that together. We can actually combine the two transformations and end up with this. So if I have an expected, if I want to transform a variable by multiplying it by something and adding something on at the end, so a linear transformation, I simply just combine the two things that we just did. So the expected value of ax plus b is simply a times the expected value of x plus b at the end. And now it can also be shown what happens when we transform the variance. I'm not going to go through it in detail. I'm just going to give you this formula here. So if I want to transform the variance, ax plus b, we end up with a squared times by the variance of x. So let's take a look at a couple of examples here. So I'm given the expected value of x and the variance of x, and I want to find the mean and variance of these. So let's get the expected value of 2x plus 3. Well, that's going to equal 2 times the expected value of x plus 3. 2 times 4.2 gives me 8.4. 8.4 plus 3 is 11.4. 11.4. And let's do the variance now. So the variance of 2x plus 3 will equal, so we take whatever's in front of x, we square it. So it's going to be 2 squared times by the variance of x, which is given as 2.1. 2 squared is 4, and 4 times 2.1 is 8.4. So the b part of the variance actually has no effect. Right, let's do another quick example. 5 minus x. So I'm looking for the expected value of 5 minus x, which is going to equal, a in this case is minus 1. So it's minus 1 times 4.2 plus b, and b in this case is 5. And minus 1 times 4.2 is minus 4.2. Minus 4.2 plus 5 is 0.8. And then doing the variance of 5 minus x, is going to be equal to minus 1 squared times by the variance of x, which is 2.1, and minus 1 squared is 1. 1 times 2.1 equals 2.1. Okay, time for you to have a go now. So pause the video and see if you can work out the mean and variance of these two parts. Okay, hopefully you've managed to do that. Here's the solutions here. And I just realized I've only done the mean for this part and the variance for this part. So let's finish off the questions. Let's do the variance here. The variance of 3x minus 2 is going to be 3 squared. 3 squared times 1.2, and 3 squared is 9. 9 times 1.2, well, that will be an 8. 10.8. And let's do the mean of this one. So the expected value of 5 minus 2x is going to equal minus 2 times by 3.4 plus 5. Minus 2 times 3.4 gives me minus 6.8. Minus 6.8 plus 5 is minus 1.8. Okay, let's move on and have a look at some more challenging problems. So, suppose a random variable t has a mean of 3 and a variance of 10, and I'm asked to work out the expected value of t squared. So we got to remember that the variance of a random variable, let's do t in this case, equals the expected value of t squared minus the expected value of t all squared. So let's use this formula here to help us work out t squared. So I know that the variance is 10. I'm looking for the expected value of t squared, and I'm going to subtract the mean squared, which is 3 squared. So 10 equals the expected value of t squared minus 9. And then adding 9 to both sides, we get that the expected value of t squared equals 19. That's the first one down. Let's have a look at the next one here. So I'm looking for the expected value of t minus 2 times t plus 2. Well, first of all, what I'm going to do is I'm going to actually expand out these brackets inside. So we get the expected value of t times t is t squared. T times 2 is 2t, and minus 2 times t is minus 2t, so they're going to cancel out. And then minus 2 times plus 2 is minus 4. So the expected value of t squared minus 4 is actually what we're looking for. And if we remember, the expected value of ax plus b equals a times the expected value of x plus b. This principle holds true for transforming t squared. So it's going to be the expected value of t squared minus 4. And the expected value of t squared is 19. Subtracting 4 will give me 15. Okay, one more problem. So we're given a probability distribution of the number of teachers who need cover in a school at a particular time of year. And I'm asked to find the mean and the standard deviation. So finding the mean we get by working out the expected value of x. So the expected value of x will be 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2 plus 4 times 0.2. Okay, so we get 0.3 plus 0.8 plus 0.6 plus 0.8 again. And then adding these up, 1.1, 1.7, 2.5. 2.5. So the expected value of x is 2.5. I also need the expected value of x squared if I'm going to work out the variance. So let's do that now. I need 1 squared times 0.3 plus 2 squared times 0.4 plus 3 squared times 0.2 plus 4 squared times 0.2. Okay, so that will be 0.3. 2 squared is 4. 4 times 0.4 is 1.6. 3 squared is 9. 9 times 0.2 is 1.8. 4 squared is 16. 16 times 0.2 will be 3.2. Okay, let's add these all together now. 0.3, 1.9, 2.9, 3.7, 6.7, 6.9, 6.9. Okay, so now I've got the expected value of x and the expected value of x squared. So let's work out the variance. The variance of x is going to equal the mean of the squares, so 6.9, minus the square of the mean, minus 2.5 to be squared. So 6.9 minus 2.5 squared equals 0.65. So 0.65. So that's the variance. So to get the standard deviation, standard deviation equals the square root of the variance. So take the square root of my answer and I get, let's do it to 3 sig fig, 0.806. So 0.806. Okay, so we got the variance and standard deviation there. Okay, let's look at the next part. The cost of cover is £185 per teacher plus an admin fee of £25. Find the mean and standard deviation of cover. So essentially it's telling me that cover equals 185 times the teacher x plus 25. So I want to work out now, I'm going to use this formula or this transformation of the variable to quickly work out the mean and standard deviation. So I need to work out the expected value of 185x plus 25. So that's going to be 185 times by the expected value of x, which we worked out to be 2.5, plus the 25 at the end. So let's get the calculator out again. So we're going to do 185 times 2.5 plus 25. And that gives us 487.5. So 487.5 487.5, and that's money we're talking about because it's cost. So I'll put my pound sign and a 0 here. So £487.50 is the average cost of cover. Let's work out the standard deviation now as well. So I'm going to start with the variance. So I need to work out the variance of 185x plus 25, and using what we've already learned, it's going to be 185 squared multiplied by the variance, which is 0.65. So 185 squared multiplied by 0.65 gives us 22,246.25, and then I'm going to take the square root of that. Let's just write this down first. 22,22246.25. 2246.25. And then I need to get the standard deviation. So the standard deviation we get by taking the square root of my variance. So take the square root of my answer and we get 149.15. 149.15. 149.15. Alright, excellent. So that's how we can use linear transformations to kind of solve a problem here. Right, that's it for this video. Just a quick note before we go, and that's that we can have discrete uniform distributions, which you'll see a little bit later in the textbook. It's pretty much the exact same like the discrete probability distributions we've been doing in these videos, except for the probabilities are all the same. So a die, for example, has a discrete uniform distribution, and that's it there. And if you want to work out the expected value or variance of a discrete uniform distribution, you can actually do it really, really quickly by doing n plus 1 over 2. So n being 6 in this case, so it'll be 6 plus 1, which is 7. 7 over 2 is 3.5. And if you did the traditional method of working out the expected value of x by going 1 times 1/6 plus 2 times 1/6, etc., and adding them all up, you will find that you get an answer of 3.5. You can also work out the variance by doing following this formula here, and that's the little note to go with it. It's not incredibly important. It can be a bit of a time saver, but the methods we've been using so far will stand us in good stead. Alright, so you should now be able to do exercise 8E and 8F, and I'll be back again with a video soon. We'll be hopefully finish the course in about 3 more videos. Okay, so hopefully you enjoyed the video, hopefully you found it useful, and I'll talk to you again sometime. Take it easy.